This is video number 4 in earthquake data series playlist, and in this video I am trying to create a real-time seismic activity tracking dashboard. And if you haven't watched, please watch the previous 3 videos so that you will learn more concepts. And if I go to the table view and let me see the data, let me show you the data. This is earthquakes data coming from USGS, and it is updated every minute. So I've used web connector to load the data so that I can periodically refresh the data. As you can see, there is a timestamp, latitude, longitude, depth, magnitude, etc. I've also created a few calculated columns. And now that we have understood briefly what is the data about, so as a first step, let me just go ahead and refresh the data. As the data is refreshed, I will get the most up-to-date data, and this is being updated every minute at the source, data source. So I will click on schema and data, and I have my latest data available for me in my Power BI data model. Now that I have taken care of it, let me create a measure, and I will create a DAX measure that calculates the average number of earthquakes occurring per hour over the last 3 hours. So let me name this measure as rolling 3-hour average equal to, and let me use the calculate function. And for the calculate function expression, let me use count rows function and pass this table earthquakes so that I'll get the number of earthquakes. And in the filter, I will try to pick up the time column from earthquakes data. This time column is greater than or equal to, I will use the now function. Now function will return the current date and time in date time format minus, let me use the time function here. I will try to use hour, minute and second. I'll use 3 for hour, 0 for minute and 0 for second. So now minus time, it will establish the starting point. It takes the current date and time and subtracts exactly 3 hours. So here the calculate function will give me the count. If I divide this filter, which is covering a 3-hour window, if I divide it by 3, it converts the total count into an hourly average. Usually a divide function is used, but I've just divided it by 3 here. And let me just go ahead and format this measure. I drag it on to the canvas. I have the rolling 3-hour average. And I have created a couple of more measures which are similar to this one. Let me just go ahead and show you those measures here. This is the one which we have already seen. And the next measure is rolling 6-hour average. I have swapped out 3 for 6 and divided by 6. And similarly for 12-hour, I have swapped out in the time function 12 and divided by 12 so that I get rolling 12-hour average. So once I drag them onto the canvas, I can see those values. Remember, every time I render this report, I'm getting the latest data, and I refresh the data. And when I'm rendering, now function is taking care of the current time. So next I will create another measure, is elevated activity. This measure returns a Boolean value, true or false. Let me just go ahead and right click on that measures table in that folder, and let me name it as is elevated activity. The measure returns true if there is a significant spike. If there is acceleration, it will return true, if not false. So first I'm creating a variable, and I will store rolling 3-hour average, which we have just computed, in it. This will be the first measure, first variable, sorry. And the next variable, let me create a baseline. So let me use the rolling 12-hour average. Let me name this as baseline 12 hours equal to, and this will be the variable for normal baseline level. And I'm storing the rolling 12-hour average in it. And once I am done with these two variables, in the return, I will return the threshold logic. Threshold logic is that I am trying to use this current 3 hours variable which I have created, which is greater than baseline 12 hours multiplied by, say, some factor, 1.25 or 1.5. So it checks if the recent activity is more than 150%, that is, we are multiplying by 1.5 of the normal baseline level. So this way, if there is that kind of activity which is above the baseline, it will give you true or false. That is the measure which I have created. So now that that is done, since I don't have to do any formatting, if I drag that onto the canvas, I can see the measure here, false. Is elevated activity false? So I'm going to use all these measures in a report page. Let me create another measure, which is earthquakes. This are. So let me just name this measure as earthquakes. This are. Earthquakes this are is equal to. Let me just go ahead and type up some variables. And first variable will be current hour. So the first variable stores the current hour. For example, if it is 14 for 2 p.m., this stores hour at exact moment the report is rendered. That is the reason why we are using now function, because the data is updated every minute or so. It's always a good idea to use now so that I have almost real-time data, right? Let me just go ahead and use R function. And let me use R function, and it expects a date time. So let me use now function within this R function, and this will be the current hour. And close the parenthesis here. In return, I will use calculate function. First, for the expression, I'll get number of earthquakes. So I'll use the count rows function over the table. And also, I will use something called as double filtering. Filter 1, I will use to get the number of rows that match this particular condition. And once I say earthquake hours is equal to current hour, and by using comma, this will act as logical and earthquakes time is greater than. Filter 2 is looking for earthquakes occurred within the last 24 hours. Now minus 1 ensures you get only that particular data. And result of this measure is it returns the total count of earthquakes for the current clock hour, ensuring old data from the same hour on previous days is excluded. That is taken care of. We have that measure also ready. And let me drag that onto the canvas. We have number 5 there. Let me remove that card visual. And let me just go ahead and show you some more measures. I've also calculated earthquakes last 6 hours. So same logic which we have used initially. And in the time function, I've added 6. And similarly, let me also calculate previous. And here also, in the calculate function for the expression, I'm counting the number of earthquakes. This is again double filtering. And this filter works together to create a slice of time where filter 1 sets the starting point 12 hours ago and filter 2 sets the end point 6 hours ago. As we have already seen, comma acts as logical AND. Calculate only counts rows where both conditions are true at the same time. So let me just try to comment that part here. So as we have seen, calculate expects an expression. We can add as many filters as possible. We have added 2. So if, for example, if the current time is 6 p.m., filter 1 greater than or equal to now minus 12 hours looks for anything after 6 a.m. Filter 2 less than now minus 6 hours looks for anything before 12 p.m. And finally, you get the result. You get the count of earthquakes that happened between 6 a.m. and 12 p.m. That is the reason we are using this double filtering. And once I am happy here, I will commit to the code and I will format the code so that I have my earthquakes previous 6 hours. And let me also go ahead and create another measure. And this measure is activity acceleration ratio. So let me name that measure as activity acceleration ratio and activity acceleration ratio. And I will use the divide function. The divide function allows us to compare the most recent activity, I'm using last 6 hours, against the activity immediately preceding it, previous 6 hours. And let me just pull that measure here. This will be previous 6 hours. And here, this number 1 acts as a safe divide. Let me type in number 1. And this is the alternate result. Close the parentheses. And once I commit to it, as we have already seen, numerator is earthquakes last 6 hours. Denominator is earthquakes previous 6 hours. Commit to it. And once I commit and I format that into a percentage. Let me type a percentage there. Select percentage. Drag onto the canvas, drag that measure, we have 87.5%. This is the activity acceleration ratio. And next is I will create a final measure, which is acceleration status. And first I will try to name the measure as acceleration status equal to, I will create a variable ratio, and we have just created that activity ratio measure, right? So let me store that value in this variable ratio and equal to, and let me use the return here. In return, I'm going to use switch, and for the expression, I will use true. By using true will allow us to do sequential evaluation. As we have already seen in one of the previous videos, the conditions are evaluated in order from top to bottom. The first expression that evaluates to true will have its corresponding result return. So here, in case if I say ratio greater than or equal to 2, and the result is rapid increase 2 times plus. Let me type it, rapid increase 2 times plus, close the brackets here, and close the quotations. And this is the final measure, and I have used several conditions. So this is the complete code block with the sequential condition 1, result 1, condition 2, result 2. Else is stable. If needed, I can add emojis or symbols. So if I search for those red circles or yellow circles or whatever, I can add them. So it looks appealing, right? When you're using this is in a card visual, this looks appealing. This is the final measure. So let me just commit to it. Now that we have taken care of all the measures, so let me just go ahead and close these things. Let me drag that onto the canvas, acceleration status. And we have some colorful icon also before that. So let me just go ahead and refresh the data. I wanted to make sure that the data is most up to date, so that way our report page also looks perfect. Next, I will use a custom visual which is called as play axis. You can click on get more visuals and download it from Microsoft Custom Visuals Marketplace. And I've already done that. That play axis custom visual is here. Let me drag that onto the canvas, and I can add some field value. So let me try to pick up magnitude category. That is a calculated column which I have created in one of the previous videos. Let me pick that. This is there, the field for this play axis visual. I can make all the changes to the animation. I can enable the color. I can change the auto start, loop, time, etc. And to save time, I've already created a dashboard. So next I will show you the final report page. This is the final report page, and this is the play axis we have already seen. These are the card visuals, new card, activity acceleration, activity status, and is elevated activity. Those are the three measures for the new card visual. And also this is the line chart, as you can see here. Let me show you the values here. And x-axis we have R, and we have all those rolling 3R, 6R, 12R, those three measures in the y-axis. And I've done minor formatting as well, so that I have my data labels, etc. It's pretty simple. This is the donut chart. Legend is region, and we have all those three measures which have been added to the values. So what happens is once I click on magnitude category, play button on the play axis, the magnitude category has certain values, right? It will roll through all the values, and the visuals also will change. This gives a kind of a real-time look, right? That is the reason why I've used this play axis. You can add any kind of fields to it, whatever available. If they are compatible, you can add those fields to the play axis visual. But in this case, I've used magnitude category, and I can change the time. Let me just add 4000 instead of 2000, so that it will loop through all the values which are there in that magnitude category. And based on those, since Power BI, all the visuals are interactive, right, by nature. So once I click on play button, all the visuals are changing. In a short time, we have created a few measures. We have understood a couple of concepts, and then we have created this final report page, and it looks good this way. If you refresh the data, you get the most up-to-date data. And once you use play access and click on play button, you can always make it as auto start and loop, so that it will continuously loop. And if you refresh the data, and you can get the most up-to-date data into your data model. And later on, if I publish this onto Power BI service, I can do the automatic data refresh maybe a few times in a day, so that I can see this dashboard. So this is perfect. This is a final report page. Thanks for watching. See you in the next video.